Your presenter today has works in the Bubin lab, has worked on analytics platform for Db2, and his focus now is integrating the Db2 ZOS and Z architecture with open systems. And with no further ado, I will pass you over to the presenter, Eberhard Hechler.
Thank you so much for the kind introduction. I really appreciate it. Good afternoon, everyone. I'm very, very happy that so many people showed up in this Spark session. As you have seen from the other Spark sessions that were here and in the parallel room this morning, this is a new idea of IDOC. I think it's a very, very good one to broaden the scope a little bit. So I have been working in the Db2 arena already for like a quarter century. I started with Db2 for MVS, as it was called, in the beginning of the 90s. Maybe some of you, the older ones, will remember. The newer ones maybe not. I have worked in distributed as well, then went back to mainframe. And since a few years, I have been focusing on open source as well as a new domain where we need to develop a point of view, integration capabilities, etc. And since about a year, I've been focusing on the Spark ecosystem as it relates to the Z systems environment. So the objective of this session I've documented here, and by the way, if you want to take photos, that's fine with me, but I will also, the charts are also available on the website. If you need the source, the PPT, just drop me an email and I will send you this as well. So the objective is really not to dive into Spark all too much. I actually would like to get the message across. What is Spark? Why is it so different to Hadoop? What makes it so relevant? And what does it mean for us from a mainframe perspective, right, in regards to Db2 for ZOS, but not only Db2, but really in a Z systems context. So from an agenda perspective, I have put together mainly 3 sections. The first one is really an introduction on what Spark is, what it is all about, how it emerged, as I said, the differences to the Hadoop ecosystem. Then I will talk just a little bit about some recent changes that IBM has developed. Some of it is available, some of it is not. So we will talk about the platform support for the open source Spark platform. And then I have another section towards the end, which is more on use cases, use case scenarios, and also integration points. And specifically, this third area here is not something that we have dreamed up in a lab environment. So it's not something that we have artificially developed in order to promote Spark and the interface to the Z systems environment. Is really derived from the work that we've done with clients. And to be quite honest to you, it was originally done more from an Hadoop perspective. I started with this already many years ago, and we have kind of validated and enhanced that a little bit, expanded that a little bit to embrace the Spark world. Please interrupt me anytime. I hope it's an interesting agenda. And my apologies up front if some of the things that you will see now, specifically in the introductory piece, may be a repetition in some of the other Spark sessions. So Spark started like maybe half a decade ago, 2009, 2010 timeframe. Not many people know, but IBM has been a founding sponsor right from day one. Right, besides other companies that you see here on the list. Of course, the prominent ones, the big ones, SAP, Google, Amazon, but also IBM. IBM sponsored this a lot, and I think we're fortunate now to leverage that investment. There have been other sponsors as well, as you see here on this chart. Now, the big thing about Spark is really that it overcomes some of the limitations that we were experiencing in the Hadoop world, specifically around the batch orientation and the MapReduce programming model that was bound towards writing back after reduced stages. So the key value of what Spark can bring to the table is really a new set of use cases that are now available that have not been possible with Hadoop. And I'll explain a little bit more. One of the beautiful side about Spark is also that it is coming with a set of libraries. You have seen this morning when Bernie was presenting in the big room over here. You have seen this with the other presentation this morning. So it comes with a set of libraries, which we did not have in the Hadoop world, right? So the Hadoop world was really mainly around data containers and around the MapReduce programming model, right? There were other components, many other components around it. They were also under the Apache, brand, almost like other efforts that were streaming related that you see here as well. So there's streaming related here as well. So the value, if you need to leave the room at the end of the presentation with one key message, it is really that Spark is all around being a comprehensive in-memory kind of processing ecosystem that comes with predefined libraries that will allow us also as mainframe people to deploy completely new use cases. So what is Apache Spark? A little more. I mentioned this. Batch was pretty much what we had to deal with in the Hadoop world. And it's not that that is bad, right? It's not that the MapReduce programming model is bad. We still have MapReduce even in the Apache Spark world. So that doesn't go away, right? But it will be complemented with other schemas, specifically iterative programming, right? The other thing is that it is based on an abstraction that is called resilient distributed dataset. The RDDs, it is actually the most important abstraction that makes up Spark. I have a little more details here. The term resilience in RDD stands for the fact that it comes with lineage information. So the distributed data definition that makes up an RDD includes resiliency data. With that, any RDD can be reproduced after failure. The other key concept is in memory. Now, if you dive into this, and there are many papers on RDDs, the original paper is a very interesting one. If you are interested, I can provide details to you on that one. All the innovative ideas around RDDs and Spark are not brand new. Lineage information is not brand new. In-memory is not brand new. Many companies, including SAP, but of course also IBM, were leveraging in-memory. Bernie was talking about it this morning, right? So everything that you can discover in Spark, there's nothing that is really highly innovative, but altogether, and of course the fact that it is free, right, that it is open source, makes it attractive. It can also be deployed on different cluster managers. We did not have that in the Hadoop world. Hadoop was pretty much, the first version of Hadoop was even bundled, right? So the data management with the cluster management was actually bundled together. That at least had been relieved. So we have an improvement there with Hadoop 2. For those of you who are still dealing with that one, Yarn is a key component that makes up the Hadoop 2 set of products. Another value or another key value of Apache Spark is the vast variety of the different languages. Spark is written in Scala, but it also supports other programming languages. So for data scientists that are used to like Python or even R is a very, as most of you I guess know, a very prominent language, they can do this today, right? So it supports, as it's written here, Java, Scala, Python, R. Maybe other languages will be added in the future. So from a mainframe perspective, it really means that data scientists who are familiar with any of those languages, the programmers in general, can, and later on I will dive into this, can use the mainframe landscape, the mainframe system with DB2, with IMS data, also data that may reside on a distributed platform, or on another HDFS cluster, or on an HBase, data warehouse system. They can use that ecosystem, run Spark on Linux on Z or on ZOS, and access data. We will dive into the details of this one. And then, of course, it comes, as I mentioned, it comes with these specialized libraries, which you have, if you have been to some of the other Spark sessions, have heard about. So I have a little more on this here. So the key idea of Spark is really around being able to write programs in terms of transformations on these RDDs. The RDDs are immutable, right? They are immutable. They contain the lineage information, as I have mentioned. They are based on in-memory, right? So in-memory concepts. And this in-memory concept, why is it so important? It is so important because with MapReduce in the Hadoop world, we had, after each and every reduce step, we had to materialize the data, right? So we had to eventually, regardless what it was, whether we were doing data scientist work, data transformation work, or whether a SQL statement was transformed, like Hive, for instance, or HiveQL was transformed into MapReduce, it had to be, after the reduce step, materialized into whatever data container was there. It could have been a plain HDFS cluster, or HBase, or Hive, or whatever. And this constant, this process of constantly writing data back and accessing it, for those of you who are DB2, and most of you are familiar with DB2, this is painful from a performance perspective, right? This is now released with in-memory. So therefore, this particular capability here is extremely important, right? Now, the Spark programming model really allows transformations or actions, right? And an action could, of course, be to write stuff back on memory, or to write it, to materialize it and write it back on any of the containers that Spark works with. And they actually work with almost every data container that you might be familiar with. It also is based on the lazy evaluation. So this is a concept where you would transform an RDD into another RDD only as you need it, right? So you are not, as we're used to it with other programming models, transforming data, in anticipation of, a downstream consuming system to use it later on, right? We're holding it back, and the transformation will only be executed when the data is really needed by subsequent processes. The other concept is that it is an application that consists of directed acyclic graphs, or DAGs. Now, you all know what a graph is, right? So the graph consists of vertices and edges. And a directed graph is a graph where the different vertices are connected, where the edges are directed, right? So there's basically an arrow. It's not an arbitrary relationship, right? So there got to be arrows. There is a direction, therefore directed. Acyclic means that you cannot, if you start at an arbitrary point in the graph, you cannot, whatever route you will take, you do not come back to the origin. And that's very, very important. I give you a very, very trivial example, which will probably resonate with most of you. Let's assume you have a spreadsheet, and you're doing some calculation in the spreadsheet, right? You are changing, maybe it's a financial spreadsheet for your own financial home financial situation. You are doing some calculations, maybe some average buildings, or some basic calculations. If you do change a certain figure in the spreadsheet, which triggers subsequent transformations, calculations in other words, you, of course, should never come back to the original field, right? Because then you would end up in a loop, in an endless loop, which you don't want to, right? So operations or the programming model in Spark consists of those directed acyclic graphs. Now the RDD is really, it really consists of these five. I mean, there's a base class, and the properties of each base class consists of these five components. You see the lineage information there. You see information on whether there is a specific partitioning recommendation, for instance, hash partitioning, or whether the distribution of the data, let's say if it is an HDFS cluster, you can include some recommendations on how the data should be distributed, right? So the list of partitions, of course, the list of dependencies on other RDDs, how you can recompute the partition, right? So the lineage information. And there are also specific subclasses here that you can define. Those here, for instance, are extra functions on whether there is an ordered list of values or sequential files that need to be built. But these are the current classes, main class, and the current subclasses. And this is the list of items or characteristics that each and every RDD is made of. Now you've seen this picture either in this form or in another form. Bernie showed it. You've seen it before here in this room as well. So the concept of the RDD is really implemented in the Spark core. And once you have data exposed into an RDD, and later I will show you how we do this in a mainframe context with data that is in Db2 for ZOS or in IMS, or could also be, of course, in an HDFS cluster. Once you expose that data into an RDD, you can process it via the APIs of any of the libraries that come with Spark, right? So for instance, you can submit a SQL statement, right? And with the data frames API that I'll talk a little bit about later when we talk about use cases, you can access via Spark relational data that sits on Db2 for ZOS, or that sits in DashDB, right? Or in Oracle through GDBC, right? Also, we have made available functions or products, virtualization layers that will allow SQL access to data that is not relational. Later on, I will talk about this a little more. So here is actually where the RDDs are implemented. These are the libraries that come with it. Here are the different languages that you can use, the different cluster managers. Most of the people that I have worked with, customers that I'm currently working with, they are, when it comes to Spark, not Hadoop. Hadoop is a little different, but Spark, they are in a state of, exploration. They try things out, right? So they typically start with a standalone cluster, right? Some people really do this with HDFS, in a pure HDFS cluster. Other people, and this is probably not all too seldomly the case, do this on Hive. Later on, I'll show a little bit on Hive as well as it compares. Hive, I think it was mentioned earlier today, it was implemented by Facebook more than 5-6 years ago, including HiveQL, the query language using Hive. Now Hive, you see, when Facebook is purely, I think more or less, really leveraging open source. However, when it comes to traditional reporting, you still need the relational representation of data, more or less, right? It's proven, it's mature, so why give it up? And this is what Facebook, of course, realized as well. So they invented Hive purely for reporting of their business, and also reporting of the business of their partners and customers. Now, the downside of HiveQL was always and it worked in a Hadoop system, right, in a Hadoop ecosystem, the downside of most of the implementations of SQL on Hadoop were that it transformed the SQL statement into a MapReduce job, with all the disadvantages that we had with MapReduce, right, materializing the data, etc. In a Spark context, we can now use in memory. So that will already have huge performance gains. So Hive, there's almost no limitation here. So Hive can be added, and of course you can add the relational world as well. Now I have some performance figures here as well. This chart, unfortunately, is a little outdated. I apologize for this, but nevertheless, it still gets the message across here. You'll see the code base here with some of the earlier efforts here. Hadoop, you see Hadoop MapReduce. You see Impala. For those of you who are in this domain, Impala is the implementation of SQL on Hadoop from Cloudera. They also recognized, rightly so, I think, that SQL on Hadoop should not be done with MapReduce. So they operated directly on HDFS. If you have heard Big SQL, and I guess most of you have heard that term, it's an implementation of IBM, sold under this Biginsights umbrella, or this Biginsights set of products, is also an implementation, right, native on HDFS. So not leveraging MapReduce. So, but you see the code base, and here you see some of the performance improvements. Shark, we should actually update this here, but Shark is the original migration of, or porting is a better term, porting of Hive and HiveQL on Spark that later was really transformed into what is now known as Spark SQL, right? So, but you see the performance improvement here, specifically compared to Impala disk. But any disk implementation, right, would naturally be significantly slower, right? So that's no surprise. I also have data, not here, but how Big SQL compares to some of the other SQL implementations. Now, usually when I talk about SQL on open source, I see this in a very mixed way. Spark was not specifically developed for SQL workloads, right? It was more developed really for data scientists, applying machine learning, algorithms, doing customer segmentation, those type of tasks. However, and this already occurred in the Hadoop world. For some of the open source people, probably in a very surprising way, when clients get their hands on open source, the thing that they look at first is existing use cases, things that they're doing already today. And they are exploring ways of using open source for the workload and the use cases that they have already implemented. Therefore, quite naturally, and this happened already some years ago when Hadoop was still the big thing, they were asking for SQL capability on open source, right? And still, later on when we talk about use cases, I'll come back to this point. My lessons learned in working with clients in this space since many years, worldwide. I'm not only working in Europe, I'm also I've had the opportunity to work with clients in the US and in Asia. Worldwide, SQL on Hadoop, and still to some degree this is even true with Spark, is still the dominant use case, is still the use case number one. Whether we like it, whether we like to hear it or not, it's just the reality. And I'll come back to this. Streaming, a little comparison here on streaming with Storm and then Graph as well. Graph, of course, is a very, very important data representation, right? The graph-oriented data containers, very, very important. Why? Because some of the use cases, like if you operate on Twitter data, where, you know, if you wanted to represent Twitter data, you know, the client base, the customer base, the participant base, who is following whom, on which particular topic, who is being followed by whom in regards to what specific topic. Those kind of, you know, relationships, this is very, very difficult to represent that in relational data structures, right? Even in column-oriented, right, data structures. So graph data representation and also the visualization of results is very, very, so the graph database is very, very powerful for those type of use cases. Now, Bernie had that chart earlier in his presentation this morning. We had already since quite some time JDBC access from Spark, right? So for clients who wanted to access relational data, any relational data, not only DB2, could be Oracle, you know, or others, but also DB, DB2 LUW, ZOS for sure, or also BigSQL, and I'll come back to BigSQL a little later as well. You were able to do this with JDBC. IBM will make this available, I think, by the end of the year, an improvement, performance improvement, under this DB2 Connect driver will still be there, but the IBM data server dialect, which is a DB2 client enhancements, will allow you know, a more performing way to access relational data underneath. So for those of you who are following announcements and, you know, some of the things that IBM is working on, and specifically in the mainframe arena, you probably have heard that IBM has already made available the Spark open source set of products on Linux on Z. That is already available since some time, I think somewhere in the third quarter. We have also announced the availability of Spark on ZOS, Spark for ZOS, by the end of the year. I think it'll come sometime December. And from a strategy perspective, right, what does Spark actually mean? And this is really more a mainframe message. There is a lot more. You cannot imagine, quite honestly, you cannot imagine how many different organizations in IBM are really working Spark related, leveraging Spark, you know, trying to evaluate and brainstorm on what Spark could mean in terms of enhancing some of the products that we have in InfoSphere information server, on the distributed side, but also, of course, on the mainframe side. And for us, the value of Spark is not that we try to promote Spark by itself, right? So we would not, our strategy is not to monetize Spark, right, by itself, selling Spark or reselling Spark or packaging it differently like we've done with Hadoop. That's not the intention. The intention really is to leverage Spark as an integral point, as an integral part of our ecosystem, and to provide integration points. Later on I'll talk about these integration points a little more in the use case section, to provide integration points that enable a broader set of use cases, scenarios, right? So that's our strategy. So we will monetize Spark by, you know, having more offerings and also optimizing some of the products that we have. And I might give you, I should give you a few examples. One of the things that has already been announced just a couple of weeks or 3 weeks ago at Insight in Las Vegas is that we will have components of the InfoSphere information server running on IOP, on the IBM Open Platform, right? The IBM Open Platform, I don't really want to dive into this today, but the IOP is like a package of open source components that serves as a host for value adds, for vertical value adds, be it now Biginsights with BigSQL and other components, but also integration components from our InfoSphere information server. So that's one thing, right? So we'll try to use Spark and other Hadoop components to optimize the deployment of our products. Another example is that, of course, we will make available Spark MLlibs within PDA, within what's known as Netisa, right? Not available yet, but that's something that we work on, where we will not replace things, but we will broaden the scope. We will include some of these algorithms. And of course, from an IDAA perspective, for those of you who are familiar with the Db2 Analytics Accelerator, they may explore that in the future. Right? From an Z systems perspective, we have now therefore made available Spark to run on Linux on Z, and shortly on ZOS to be able to access data and expose it into Spark. Right? So that's the strategy that we're following. It allows then, bottom line, faster analytics, not only batch. Batch, you were able to do this already with Hadoop in a fairly nice way, but also real time, right? In a real time way with new use cases. Federation, I'll come back to this one here definitely. One of the key points, one of the key strategic imperatives for us is to finally, do what we were preaching to our clients already since many, many years. Namely, to move workloads, applications, and analytics to where the data is. We did this only in a partial way. With the Db2 Analytics Accelerator, this was a very, very good thing, right? Specifically within database analytics. But when it came to the broader analytics, sphere, we didn't really do this. If you would really look at use cases, most of the use cases were characterized by accessing the data, transforming the data, moving the data, putting it on another platform, right? Maintaining it there. This whole information supply chain, the data flow that we were, imposing our clients with, was a very, very cumbersome, a very painful thing. So one of the key aspects of Spark, one of the key value points of Spark is that for data scientists, we will be able, at least to a large degree, maybe not 100%, but to a large degree, we are able to federate, to provide federation for data scientists, right? Leaving data in place. We do this on historical data, OLTP data. It's Java-based. This is what I was talking about. We can avoid unnecessary ETL, not only with in-database transformation in the Analytics Accelerator, but also by using data that sits on an HDFS cluster, right? So that's a little bit on what the meaning is of Spark for us from an R&D perspective, from a development perspective. Now, this is what I mentioned, right? So this is this federation approach, the federated analytics. You can really phrase it in that way, to finally be able to provide federated analytics. And you see these yellow areas here, these yellow boxes, which are really Spark nodes, or you can actually view them as RDDs. So the concept works in such a way that through various mechanisms, through the GDBC connector or through other virtualization layers that we have, which I will present in a while, we can now access relational data, non-structured data, data that sits on an HDFS cluster, or also on a GPFS cluster for that particular purpose, or on Hive, or on any other relational engine. And through the APIs, for instance, the data frames API from Spark, we can expose that data into an RDD abstraction. And once it is available in a set of RDDs, we can then operate, the libraries that we have available, whether this is now SQL, or whether this is machine learning algorithms, or whatever. So the purpose of why we provided this is to again leave the data in place and do the operations on data that we would expose in RDDs. And when I say RDD, I mean in memory. Right? So it would essentially mean that you can now expose data into Spark resilient distributed data sets, develop models there. And once the model is developed, it can then be stored in whatever container is appropriate. Could be in Db2 again, in Db2 for ZOS, for instance, again. Here is an example of how this would, for instance, work on a platform that's entirely on the mainframe. Right? So we would have the transactional, and this is a banking example, transactional data that sits entirely on Db2 for ZOS. It could also, for that purpose, sit on IMS. It doesn't really matter. It could also be IMS transactional data, right? And data that is of completely non-structured nature here, that sits on, let's say, an HDFS cluster that's being managed by Biginsights that runs on IOP, on Linux, on Z. It can also run on another platform, could be the distributed platform. Right? And whether this is now really external data, my personal opinion is, most clients that I have worked with, before they really reach out to external data, meaning Twitter or Facebook or the weather data, you know that IBM has partnered with that company or acquired the company. Most of the companies that I have worked with start with when it comes to non-structured data, they start with their data that they have in their house, in their enterprise. Could be email traffic, could be call center transcripts, right? Could be web log data. But that's an example of how, the Spark data scientist would work with the Spark ecosystem that he may be familiar with anyhow, right? Or a similar ecosystem that he might be familiar with, where he works with it by being able to access Z data, right? Not moving data to another platform, transforming it, aggregating it, preparing it, cleansing it, but doing it in memory through Spark. We have also announced back in 3 weeks ago at Insight in Las Vegas the so-called Rocket Mainframe Data Service for Apache Spark ZOS. IBM is great in inventing big names, so long names. This is another long name that we came up with. I call it the data virtualization layer. And the beautiful thing about this virtualization layer is that it will allow you to access the data, non-relational data in SQL. This is very nice, I think. So you can access in SQL SMF log records, VSAM records, other data. Db2 for ZOS and IMS, for instance, you access already through the JDBC layer, right? The JDBC interface. So with the Rocket Mainframe Data Service for Apache Spark, you would now be allowed to use SQL, right? Plain SQL to access the data, expose it into RDD, and do data scientist tasks, or also to submit SQL statements against it. Now, my personal opinion, whether this is necessarily SMF, remains to be seen. It really depends on the analytical insight you would be interested in. You could also store SMF data, for instance, in the Db2 Analytics Accelerator in relational formats. You can use the new IDAA loader in a very elegant way for that. Do basic transformation, actually, only basic transformation of SMF log records, store it in the Analytics Accelerator, run the TDS, the Tivoli Decision Support, Z product via Db2 on the Analytics Accelerator and get your reports. However, so that is an existing scenario, right? However, and this refers to plain reporting, right? Existing reportings via Cognos, for instance. However, some clients that I have talked to, they're interested in cross-ZOS subsystem analytics trying to investigate on some of the error situations, right? Some of the odd situations that occur in, in the Z systems world. So to analyze cross-subsystem, interaction and behavior. For that, you may want to develop new models, and that requires Spark. That requires, machine learning algorithms, and therefore, for those type of analytical insight, this new virtualization layer may actually be a very, very useful one, right? So it remains to be seen basically by you, the clients, whether you are using the analytics accelerator or Spark for that particular purpose. Now, the last section before I call it here for maybe some questions or a point of view that you have is on scenarios, use case scenarios, and also some integration points. Now, as I have mentioned initially, I had the opportunity to really work with many, many clients globally, and specifically on use cases. Use cases, we have learned from customers what it is that they're doing today, what are they exploring, are they already in production, and so on and so forth. And based on that work, it really turns out that bottom line, there are like 4 categories of use cases, right? 4 types of use cases that I have listed here. Maybe there are more, whenever I talk to a client, whenever I have an opportunity to work with a customer, I get a little more insight, etc. But the categories are still the ones that I have captured here on this chart. The first one, as I said, is really SQL. It's really plain good old SQL, but on open source. And a company like Facebook has a company like Facebook has done this as well. Other companies have done this as well. Huge financial services organizations that I have worked with are highly interested in this, mainly for offloading. They like to offload data to an open source data container, but they would like to do it in such a way that they can still SQL the data. Right? Now, whether HDFS is the best way to do this, or maybe the analytics accelerator would be also a candidate for doing this, it remains a little bit on other usage scenarios, right? So that's still a very, very... Another one is information integration. So really quite a number of clients are using open source to dump the data, to do some transformation, aggregation, preparation, right? They do this in order to prepare the data for other downstream consuming systems, right? The use case that Spark is most relevant for is the third one here, right? Doing data mining, applying machine learning algorithms, allowing data scientists to, use open source. And quite frankly, Spark, and how many of you are really from the mainframe arena? I would be highly interested. Who? Okay, many, many people. So really one of the key values for you from a mainframe perspective is that with Spark, you see, in the past, if you looked at your role as an IT organization, when it came to how you were interacting with line of business, whether this is marketing, finance, customer care, doesn't really matter, is you were providing data, right? You were basically a data source provider to, let's say, a marketing organization. And they then built their data lake, or they have built their, they were using open source data containers to store data, and were exploring the data, either transforming it, applying some analytics or whatever. I think the opportunity you have now with Spark and IBM's investment in embracing Spark, making it available on ZOS with all the federation stuff, the value for you from an IT perspective is that you can now provide higher level services to your line of business organizations, right? You can provide them with a Spark ecosystem, right? Where you would not have to just give them some data and do the transformation and the movement of the data. You, with the Z ecosystem, you would provide the Spark platform for marketing, finance, customer care, you name it, to really access that data, leave it in place, access it, and applying business-oriented analytics. Right? This is a key value, and I think also a paradigm shift for IT organizations today. Right? The last, and this is really the third one is really the sweet spot of Spark. It's something where Spark really fits in, and this is what clients are exploring. Right? The fourth one here, performing system T and natural language processing, this is the sentiment analytics, affinity relationship thing, is something that IBM has promoted since at least half a decade, even longer, maybe 6-7 years. System T is an old thing, it's not brand new. It's new on Hadoop, but not new by itself. This is something that clients are all interested in, they're all talking about it, but it's not really something that's being widely deployed. Right? Now, I have a little more details on this, on the different categories, and in terms of what are the tasks, what are the data sources, the role, right? So there's a lot of more details here for this one, which I don't really want to lead you through in all this detailed fashion. I have this for each and every of these individual categories. If you're interested, I leave it to you to read through this and dive into this. Interesting here, the third one for the data scientist. This will now, of course, allow all different types of data sources to be accessed. Whether this is relational or external non-structured or even company internal non-structured, doesn't really matter. So I leave it to you to dive into this in a quiet moment. So I just have maybe 2 or 3 charts, and then I open it up for maybe some questions, or perhaps some of you has a point of view that you would like to share. Now, I've mentioned this already. The Spark data frame API, from a SQL perspective, is very, very important. It has been made available earlier this year, so it's not something that existed already a long time. It's less than a year, actually. And you could view this almost like a capability of Spark to view the Spark data in relational format. Right? So you could expose the data in relational structures. Very, very nice. Data frame API is available in all these languages that I have talked about at the beginning. So Scala, Java, Python, R. Supported formats and sources are many. It's not only JDBC, but also Hive, JSON formats. Right? JSON also something that we support in Db2 for ZOS. And the benefits, of course, easier manipulation interface, similar to SQL, higher abstraction, right? You can basically apply SQL. Of course, not the same power. We need to be a little cautious. The original Hive query language and also what later became Spark SQL is, of course, not ANSI compliant. It doesn't really support everything, right? So you cannot compare this entirely with what we are known from SQL support in ANSI and with, for instance, Db2 for ZOS. By far not. But still, customers that I have talked to, they can cope with that. It's enough for them. Right? So here I have a little picture on how that works. So you would basically come from Spark SQL. You can use the JDBC access or the enhancements that we provided to access Db2 for ZOS. Underneath, you may even leverage the IBM Db2 Analytics Accelerator for acceleration purposes, right? And it's basically done through data frames, and the RDD method will expose the data into the RDD abstraction. So I think you're getting the idea that the RDDs is, I think it is the key concept, the key abstraction that makes up Spark. If you really would like to understand Spark, I think you should read some of the original papers on the RDD. It will have an eye-opening kind of an effect for you to really understand what it is all about. Right, and Big SQL, IBM's SQL implementation, we came up with this already some time ago, maybe 2.5 years ago or something, or maybe it's close to 3 years or 2.5 years ago. We will have on Linux on Z Biginsights with IOP. So IOP, the IBM Open Platform, free of charge, downloadable with all the open source Hadoop, including Spark products. And then on top, the Biginsights analyst and Biginsights data scientists and other components, including even InfoSphere information server components. And Big SQL is included in the data scientist component. This is how it works. And of course, Big SQL and Spark SQL, they coexist in a very fruitful way in terms of that. Of course, Big SQL being based on Db2 and also allowing federation from a SQL perspective, right, has a much richer SQL set, right? So it's much richer. It's as you know, it's ANSI compliant. But Big SQL, if you look at it downwards from the point of view of what data can I access, can I access HDFS, HBase, Hive, Cassandra, Parquet, and so on? Of course, then Spark SQL is the richer SQL implementation from a data source perspective, right? So therefore, I think, and IBM is of course, thinking in all different directions here. I just wanted to expose you to this. There is of course a very fruitful kind of a synergy between these two approaches. On one hand, with Big SQL from IBM to leverage the rich ANSI SQL set, and then from an Spark SQL perspective to leverage the rich kind of a capability to access data that resides on a heterogeneous kind of a data container landscape. With that, there's a little more in the presentation, some details on other use cases. But I would like to reserve maybe just a couple of minutes or so for maybe some questions, or maybe you have a different opinion about use cases. Maybe you have different opinions. Here we go.
Question. I heard from cloud data that they foresee predicate pushdown of statements towards Hadoop, for instance.
Performance. Sorry, I couldn't get the correct question.
Yeah, they foresee predicate pushdown for statements to be executed on Hadoop.
We have
the query environment, and I wondered how IBM sees it, because they do the same with IDAA. Actually, why don't they do it for Hadoop?
Yeah.
Why do they focus on Spark rather than
Yeah.
pushdown and the IDAA integration?
Yeah. So that's a very, very good topic. The question, for those of you who couldn't understand, the question was around predicate pushdown, right? Where are we in that particular paradigm that I have talked about in regards to predicate pushdown? There is still, to be honest to you, quite a bit to do in that particular respect. Big SQL has already some of this. With Big SQL and the federation component of Big SQL, we can do this already, right, to some degree. This was already, long before we implemented this in Big SQL, a function that was that we delivered. On the Spark SQL side, that does not exist today. On Spark SQL, the concept is more not to leverage, at least today, the SQL engines underneath, right? The concept of Spark SQL is more, you have a very heterogeneous data source landscape underneath. Therefore, the philosophy is more, you see, accessing the data first, exposing it into RDD, and once there, then you can apply whatever library. Could be SQL, could be an ML algorithm, could be exposing it into a graph data representation, whatever. So I don't know for sure, but I think predicate pushdown may be something that is maybe less high from a priority perspective in Spark SQL. Right. Any other question? If not, I think, here we go. Good.
We've got tools like Splunk, which analyze already performance log data for monitoring, for performance tuning, etc. And currently, IBM is very heterogeneous with regard to these tools, and you have to all puzzle them together. Can we expect from IBM an evolution towards a more homogeneous set of monitoring and tuning tools, like application performance management tools and plan monitoring?
Okay, so that's a very difficult question. So the question was around what we can see from IBM in regards to monitoring, right? Monitoring tools for this broader kind of a landscape that we've seen, right? Now, of course, we have already wonderful tools, right? Monitoring tools, but quite openly, a monitoring tool that would, have one graphical user interface, etc., one appearance that would monitor all the different tasks, that may be executed on a Db2 for ZOS, accessing IMS, things that may happen on a Cloudera cluster underneath, and then maybe an Oracle system where you access. That is something that we may not see for quite some time. But within the Z ecosystem, you have already quite something available today. I hope it was interesting. Thanks for your question. I hope you enjoyed this session. If you have any other questions, just don't hesitate to also send me an email. Right? I'll be happy to respond remotely as well. Thank you. Thank you, guys.